Right. One last sorry tale from the wonderful fun world of social psychology. And because I think the point has already been made, this you can regard this one as optional. Watch it if you like or don't. It's a more recent study, and if the combination of the social and the psychological causes problems, as it seems to, it doesn't hurt, it doesn't really help to throw the word evolution in there, which always makes things more difficult. The case in question has given rise to a beast known as Dunbar's number, another element I wish were stricken from the record. And the fears in question in this case relate to Facebook and Twitter, social networking. Maybe you've heard of it. It seems to be a common thing these days. The Irish Times on September 16th, 2010 ran this article by Dick Almstrom, who really should know better as a science editor, reporting from the British Science Festival. It's a good headline, that, isn't it? Falling in love puts friendships at risk. We could all relate to that. I want to draw your attention to the paragraph that I've circled there, which I've blown up at the bottom. It has to do with how many friends people have. And of course, when Facebook came along and started calling contacts on Facebook friends, old fuddy-duddies like me got really worried. They're not your real friends. And this is a study that sort of follows that. Your actual circle of friends was much smaller and could not physically exceed a maximum of 150 due to a limit set by the brain, he said. This figure has become known as Dunbar's number. What do we make of this? Well, first of all, it's terrible journalism. Brains and journalists do not mix well. The brain faces us with enormous conceptual challenges, but all too readily in everyday talk, we simply ascribe magical powers to the brain, magical competences. We invent jobs for it to do. And here it is, limiting your number of friends. If you don't think there's anything wrong with the reporting that we just saw, then please stop right here, take a break, come back and watch it again, because it's really, really bad. The idea that your brain, which is a piece of meat, remember that, could set a physical limit to your number of friends. Friends is not a concept that works well with meat, except at a barbecue. So, let's have a look at the science behind this. In 1992, the prominent, respected, and still current Oxford University social psychologist Robin Dunbar came up with the idea of looking at brain volume as indexed by the ratio of the neocortex to the rest of the brain, and comparing that with the typical size of the groups in which 36 different kinds of primate lived. Primates, remember, includes monkeys and apes and a variety of other animals to whom we are more distantly related. And he found a correlation. There's nothing like a correlation to get the juices flowing in the morning. A correlation sounds like science, doesn't it? There's a correlation. There's a correlation there. And in a follow-up study, he added humans to the plot because humans are not on this. Before we add humans to the plot, let's just be clear what the variables are here. The x-axis is a ratio. It's the volume of the neocortex to the rest of the brain. Now, when you survey the animal kingdom, not all animals have neocortices, not all animals have brains. Those of us who are blessed with brains, some of us have cortices. All mammals do, and certainly all primates. And furthermore, as you look at animals, primates that are more and more similar to humans, you find an increasing ratio of neocortex to the rest of the brain. That is, the neocortex, from an evolutionary point of view, is more recent than the older structures which are buried deep in the brain. And humans, it should be noted, have this peculiarity. We have huge neocortices. We are what giraffes are to necks, we are to the neocortex. So, in a follow-up study, he added humans to the plot. Not because there's a known group size for humans, think about it, but because we can construct this ratio for humans, and we can use the model, the straight line that we would fit through those data, and thereby come up with something like a prediction. Now, the scales on this plot are log scales, and COVID-19 has taught us all a lot about reading log scales. I'll show you these data on linear scales shortly. But the idea that one might predict an optimal group size for humans is the kind of thing that lots of people seem to want to find. We like telling each other what we should and shouldn't do, don't we? I want to say that once more, we're faced with spectacularly bad science. We'll talk about the x-axis variable and its anthropocentricity. It's a weird one. We'll talk about the y-axis variable. It's specious. The group sizes were cherry-picked, and we'll talk about that a little bit. So the x-axis is a problem and the y-axis is a problem, but the addition of humans to the plot is completely bonkers. It's not allowed in any scientific analysis. I'll explain why in a minute. But notice what the outcome is. Look, what kind of magical knowledge has science produced here? It tells you your Facebook friends aren't real friends, and it tells you should be, your optimal group size is 150. And that doesn't matter whether you're a hermit or whether you're a K-pop star. Your optimal group size is 100. We love telling each other what to do, don't we? Let's start with the x-axis variable. That's the ratio of the neocortex to the rest of the brain. Now, I mentioned that it is an anatomical peculiarity of humans. We have huge neocortices. Lots of animals have anatomical peculiarities. Giraffes, as we noted, have long necks. Penguins stand around in the cold all day and don't seem to mind. Birds of paradise do wonderful dances. We have huge forebrains. Imagine giraffe scientists setting out and using neck length as a lens through which to study other animals. That wouldn't make any sense, would it? They have freakishly long necks. Giraffes really have freakishly long. It's a kind of a giraffe thing. But to view other animals through the lens of the giraffe neck would give an entirely giraffe-centered perspective on things, right? So humans here are outliers. We don't fit a regular pattern. So this is not an appropriate measure to go drawing comparisons between humans and other animals. So that's the x-axis. Let's have a look at the y-axis. Natural group size. This invokes a notion of nature and society in which there is such a thing as a natural group size. Nature here is some kind of mother goddess, I think. But most primates don't have clear group sizes. And when you dig into the data, you find that Robin Dunbar was very careful in selecting which groups that he observed made it into the plot. He excluded, for example, any primates that live in interaction with humans. Lots of primates live in interaction with humans. Human-primate interactions are common as muck in India and Thailand. So the view of nature that's included here makes humans something that lives outside nature and assumes that animals are polluted or changed in their essence when they encounter humans. He also retrofitted human history onto this and cherry-picked occasions from the past when a group size of 150 could be found. I'll guarantee you, if you chose a group size of 6 or 10,000, you could find plenty of examples in human history where people congregated in sizes of 6 or sizes of 10,000. But 150 was a unit in the Roman army, for example. Could be a village size. There are villages of about 150 people. So this whole work is driven by a romantic yearning for a pre-industrial, fictional, natural state. It's a religious or romantic vision. It's not proper framing for a scientific study. But those are not the main problems with this. The main problem with this is adding humans to it. It might be fine to take an anatomical characteristic and compare primate species. Choosing one that you have a vested interest in because you're best in the class at it is an odd choice, but you could do that. But then to put yourself into that plot, what's going on there? Well, when you have two variables and there's a relationship between them, that's really easy to find, two variables that have a relationship between them, and we get a correlation. So we can fit a straight line. It's the simplest possible model. It's so simple a child could do it. It's so simple a scientist with a childlike curiosity could do it. It's so simple, we need to be careful. If you observe two variables that are correlated, for example, wealth and height, probably correlated. I'm not sure. You might find a weak correlation, but there's so much going on that lots of things are correlated with lots of things. When you find a correlation and you fit a model, if your correlation is strong and the points cluster around the line, then that can be, if you've done your work carefully, that can be a good basis for making predictions about the future. And for example, for taking an animal for whom, or a case for whom one variable is known and the other is not, and predicting the value of the second variable. But that is a legitimate procedure only over the narrow range in which you observe the correlation. Things outside that range are not fitted by your model. Your model has nothing to say about things that lie outside the range. Any two variables, which are continuously related, will exhibit a linear correlation over some narrow range. I might point to the fact, as I sometimes do, that the Earth appears to be flat where you are because you're looking at a very narrow, limited range. That flatness doesn't extend to the whole Earth if you extend that range. So that's the basis of how you handle correlations. So now we're going to have a look at the data that funded this study. Those are the original data. And you can see these are linear plots now. We understand linear plots much better than log plots. The left is a linear plot, the right is a log plot. On the left-hand side, you wouldn't try to fit a straight line to that. What you would observe is that there's a bunch of animals who have virtually no ratio because they have virtually no neocortex, and then there's a mess. When you log transform these, put them on log scales, you sort of see that correlation, and good for you. There's humans. We're the black dot up in the top right-hand corner, and as you can see, we're outside the range over which the correlation was established. We're outside the range on a log scale. That's a transformation the scientists chose to make. On a linear scale, this shows us where we really are. Look where the human point is and look where the other primates are. Any extension beyond the bounds of the supposed correlation is illegitimate. This is outrageous. So Robin Dunbar's conclusions about human group size are commonly reproduced in the press. You will find Dunbar's number spoken about as if science had found out something here and used to justify claims telling people what they ought or ought not to do or be or what's natural, and wagging fingers at kids on Facebook saying they're not your friends. This is not how science is supposed to work. And this is the fourth case. And these are probably the best known studies in the whole of social psychology. What is going on here? Well, once more, Dunbar is responding to social fears. The internet came along and social media changed human patterns of interaction massively. Of course, we need to study this and we need to understand this, but one of the things any change does is it gives rise to fear and anxiety. And here, not now, but when Facebook first happened, it was largely young people using Facebook. And young people are scary. You're scary. Social media and the internet give rise to a whole lot of concerns, and you will see this pattern repeated again and again and again. You will find fears giving rise to poorly thought out studies that draw normative conclusions telling you how you should or should not live. Interesting findings take control of the imagination and lead to wild interpretations. And it's this drive for normative conclusions and conclusions that can be used to guide people's lives. That is the real problem. So when it comes to normative social psychology, I'm just going to say, at this point, I'd have to say no.